7.7 is about transformations. We're going to learn to use transformations, and our essential question, how do I transform plane figures using translations, rotations, and reflections? You can find the rules on pages 364 and 365 in our current textbook. Otherwise, we'll go through them one by one. A lot of different vocabulary terms that we will break down as we go through this lesson. When you are on an amusement park ride, you are undergoing a transformation. A transformation is a change in a figure's position or size. Translations, rotations, and reflections are types of transformations. The resulting figure or image of a translation, rotation, or reflection is congruent to the original figure. A translation slides a figure along a line without turning. Let's talk about a few of those different terms. Congruent, remember, is equivalent to. It just means that that same exact shape, might be facing a different direction or moved to a different location. So with these transformations, we're transforming the position they're in. For translations, it's just a shift left and right, up and down. You can see to move right A units or left A units, we would add or subtract from the X coordinate. To move up B units and down B units, we would add or subtract to the Y coordinate. Graph the translation of triangle ABC 2 units right and 3 units down. So we need to move every ordered pair 2 units right and 3 units down. So we have points A, B, and C. We're going to add 2 to all of the X's and subtract 3 from all of the Y's. A is located at -3, 4. The new A, or image of A, is -1, 1. We got that by adding 2 to the X and subtracting 3 from the Y. B is currently at 0, 2. The new B, or image of B, will be at 2, -1. We added 2 to 0 and subtracted 3 from 2. C is located at -2, 1. The new image is at 0, -2. There's the new image of the triangle ABC after being shifted 2 units right and 3 units down for every vertex. We can do the same with a quadrilateral. We're going to shift ABCD 3 units down and 5 units left. Now that was written opposite of what we would think as far as X's and Y's. So we need to be careful to flip that around in our head. We're going to subtract 5 from each X coordinate and subtract 3 from each Y coordinate. Here were our points. A was at 1, 4. The image, -4, 1. You can see our rule. We're subtracting 5 from all the X's. That's 5 to the left. And 3 from all the Y's because it's 3 down. New image of B is -1, 0. C is -1, -4. And D, -4, -5. There is our quadrilateral after being shifted 3 units down and 5 units left. A reflection flips a figure across a line to create a mirror image. Our current line of reflection is the y-axis, so those two shapes are reflected with the y-axis as their line of reflection. We could also reflect across the x-axis, so here are the rules. For the y-axis, we multiply each x-coordinate by -1. If we go back for a second, you can see that's obvious in the points. B was 1, 4 and became -1, 4. C was 3, 4 and became -3, 4. A was 1, 1 and became -1, 1. When we reflect across the x-axis, it would be the opposite of that. We would multiply each y-coordinate by -1. So let's graph the reflection of quadrilateral ABCD across the y-axis. First we need to know all of our points, and then we're going to multiply the x-coordinates of all of them by -1. So we write down all of our original ordered pairs, multiply the x's by -1, and we have our new image points. When we go to graph those, you'll see that it's been reflected. It's almost as if we folded on the y-axis and imprinted it on the opposite side. Let's graph a reflection across the x-axis. Now we're going to be multiplying the y-coordinates by -1. Start with our ordered pairs. You can see we multiplied all the y-coordinates by -1 to get our new points. And it's the same idea, but now we fold at the x-axis to imprint on the opposite side. Lastly, we have rotations. Rotation turns a figure around a point called the center of rotation. So now our shape is going to not just flip, but move in a clockwise or counterclockwise direction. We have 3 rules for this. 180 degrees, it does not matter if you go clockwise or counterclockwise because you'll end up in the same spot. We multiply both of the x-coordinates and the y-coordinates by -1. If we move 90 degrees clockwise, multiply the x-coordinate by -1 and then switch them. If we go 90 degrees counterclockwise, we multiply the y-coordinate by -1 and then switch those. It will be helpful to have these rules in front of you as you're working. Graph the rotation 90 degrees counterclockwise about the origin. Let's go back. We're going to multiply the y-coordinates by -1 and then switch the x and y. So you can see what's actually been done here is they're trying to do multiple things at once by flipping them around and multiplying what was the y-coordinate by -1. If it's easier for you to picture it before flipped, we would multiply all of these right here by -1, which is what's happening here, and then we would flip them around. So that's how we get -4, 4, -1, 4, and -1, 2. It's a little hard to keep track of, so you may want to write it out in a way that makes sense to you. And when we graph that, you can see it's been rotated. So our center of rotation is in the middle, the origin. So A's been rotated over here, B's been rotated, and C's been rotated. Graph the rotation of triangle XYZ 180 degrees about the origin. This rule is a little bit easier. We just multiply everything by -1. And our new image is right there. Make sure your notes are filled out completely. On the left-hand side, write questions that could be answered from the material in your notes. Review your notes, highlight, underline, etc., and complete the summary before class.